Hello, this is Sebastian Lehrich from the CloudScale project. In this video I'm going to show you how to take measurements of the previously instrumented system by using the log generation of the previous screencast. Therefore, we can now start the measurement for the TPC-W system. As a reminder, we modeled the TPC-W system here, and we had one source demand here for CPU, and we specified that we will consume 0.1 CPU units. That was an educated guess, this number here. What we now actually want to do is to measure the real demand in a system. For that, we first start our message queue server, in my case Hornet queue, that takes or that collects the measurements. So the idea is we have this server, Hornet queue. We can start it with this batch file. You can double click it and the server starts. And this server now provides a message queue that collects the measurement data. Our instrumented system sends asynchronous messages to this server. And we attach next a monitor to this server that can visualize incoming measurements. The monitor is the CloudScale monitoring tool, which comes with the CloudScale tool suite. So we just started as a Java application, and it would look like this. I already started it in the background. The monitoring tool attaches itself to our Hornet queue server and visualizes different kinds of measurements. Response time, CPU utilization, main memory usage, and hard disk utilization. To get to the measurements, we actually have to start our web application. So we have to start the web server. For that, we connect to the server we use for the web server. So, for instance, we connect via SSH and then start the Tomcat server we are going to use. So for that, we pin the web server to CPU number 1 via task set, because we want to get rid of scheduling effects when doing the measurements and want only to consider one CPU. And I'm having a system with 2 CPUs at hand here. And I want actually to start the Tomcat 7 service. And now I pinned it also to the CPU. I want to start it, not to stop it. Yeah, there is a typo in task set, so it's like this. And if I execute it correctly, I should get an OK for starting the web server. And as you can see already in the background, in my monitoring tool, we get some first measurements here. For instance, we see that there are 2 CPUs in our instrumented system, CPU 0 and CPU 1. We are mainly interested into CPU 1 because that's the one we pinned our web application server to. The main memory usage is relatively constant, and we observe basically 0 hard disk utilization on our server. We don't receive any response time measurements because we did not generate any load on the system yet. To test this load generation, we could, for instance, go into a web browser and access our web page manually. So we could, for instance, open the web browser, enter the IP address of our server and the location of the application that runs. By pressing return, we would go on the web page. This one shows now the TPC-W web page. And we see that we get a response time measurement for this call. Whenever I press reload on this page, I will get another measurement. As I do not want to do that manually by pressing the reload button, I can also use my load generation JMeter for that. I already configured in a previous screencast. So we could just open this configuration in JMeter and hit the play button in the menu bar of JMeter to start our load generation we pre-configured already. So by pressing the start button, we see that now several measurements arrive in our monitoring tool. We see that the response times are relatively constant around this area here, that the CPU is now utilized, especially CPU number 1, and that main memory is slightly increasing at the moment. The reason for that is that each call to our web page requires a new session, and the session is allocated in the main memory by our Tomcat server. What we can already now conclude is that the instrumented method, which is the print hello message, causes CPU utilization. Therefore, it's a CPU bound operation, and we have to specify a CPU demand for that. We already estimated that correctly in our model. Still, the 0.1 seems to be a bit inappropriate because we don't have a really constant load here, but it seems to be a distribution. And what we actually want to get is the distribution of this load. To get clear measurements, we have to restart this tool now because there is a warm-up time. There may be some operating system effects we cannot observe. So what we actually have to do now before continuing the measurement is to restart this tool here to get clear measurements. Okay, so I close this window for the time being and go to my CloudScale tool suite. Select another start of the application and then observe clean measurements. So this now does not include any startup time. I would now have to wait for the time I find appropriate for taking measurements. Assume I'm now already satisfied with the measurements here. I can write these graphs now to a PDF file, which I did now, and when I close it, also all measurement data is stored. So I close it now. And what I can see now in the default folder of the monitoring tool, it's C data per default, is that I got to a lot of data files here that all store the data I just measured. As I hit the write to PDF button, I for instance get a nice image for CPU utilization or for the response time measurements. And basically that's it. That's for setting up the measurement and executing the measurement. In the next screencast, we will learn how to come from these take measurements to the demand specification as needed for the CloudScale Analyser. So how to come from these measurements to the value shown here. Thanks for watching.